Basically, energy is the ability to do work. If this boy is playing or doing some work, that means he has got energy because of which he is able to do some work or play. So energy is the ability to do work. If you do not have energy, you won't be able to play or do any sort of work. So how do we define energy? Energy, it is the ability to do work. Now, the object on which work is done will gain energy, while the object which does work loses energy. So, for example, here is a box and I am pushing this box. That means I am doing work on this box. So, the object on which work is done, because I am pushing this box, that means I am doing work on this box. So, this box will gain energy and the object which does work loses energy. That means I am going to lose energy. Once again, energy is the ability to do work. If I am doing any work, or right now if I am talking or teaching, that means I am doing work. But if I am doing work, that means I have energy. So energy is the ability to do work. Now, the object on which work is done gains energy, while the object which does work loses energy. So in this case, if I am pushing this box, that means I am doing work on the box. So box will gain energy and I will lose energy. Another example, I am raising this hammer. If I am raising this hammer, that means I am doing work on this hammer. So hammer will gain energy and I will lose energy. Right? Now the second case, the hammer is being brought down to hit on this nail. That means hammer is doing work. So hammer will lose energy and the work is done on this nail. So the nail will gain energy. So energy is the ability to do work. The object on which work is done gains energy, while the object which does work loses energy. Right? Now, energy is a physical quantity and it exists in various forms. Now, physical quantity means we are able to measure it. Energy is a measurable quantity or a physical quantity. That means just like length or distance or time, we are able to measure energy and it exists in various forms. There are different forms in which the energy exists. Say for example, heat, light, sound, chemical, nuclear or solar. So these are different forms of energy. So energy exists in different forms and we are able to measure energy. Now units of energy and work are same. Work is basically force into displacement. So SI unit of work is joules or Newton meter, which is same as joules, and CGS unit is dyne centimeter, that is ergs. Similarly, for energy, the SI unit is Newton meter, which is called as joules, and CGS unit is dyne centimeter, which is called as ergs. Now, what is the relation between joules and ergs? 1 joule is 10 to the power 7 ergs. So, this is very important conversion that you need to remember. SI unit joule is related to CGS unit ergs by this relation. It is 10 to the power 7 ergs. 1 joule is 10 to the power 7 ergs. So let's understand how we get this 10 to the power 7 ergs. Now here I have made two columns. One is SI unit column, the other is CGS unit column. In SI unit, 1 Newton, the conversion is 10 to the power 5 dynes. And 1 meter we know is 10 to the power 2 centimeter or 100 centimeter. Right? Now Newton meter when we say, so Newton is 10 to the power 5 dynes and meter is 10 to the power 2 centimeter. So Newton meter is basically 1 joule and 10 to the power 5 into 10 to the power 2, 10 to the power 7 dynes centimeter. So 1 joule is 10 to the power 7 ergs. So this is how we get. So the relation between joule and erg is 1 joule is 10 to the power 7 ergs, and this you need to remember. Now let's see what are the different types of energy. Basically there are two types of energy. One is the kinetic energy. Kinetic energy is the energy associated with the object when it has got motion. So whenever the object is in motion, it will have energy which we call as the kinetic energy. Here in the picture we are seeing airplane flying, woman cycling, car moving, windmill rotating, boy skateboarding, boy kicking a ball. So all these objects are in motion and they have energy which we call as the kinetic energy. Now there is another form of energy, that is the potential energy. Potential energy basically is the energy due to the position of the object or the configuration within the system. So energy possessed by the object due to its position or due to the configuration, the arrangement within the system, that is called as the potential energy. Now here are some pictures. A roller coaster at its highest point will have the potential energy. Water stored in a dam will have potential energy. Apples on the tree will possess potential energy. Stretched arrow, pulled slingshot. So all these are the examples of potential energy. That means they have energy because of their position or because of the arrangement within the system. So these are the two types of energy, the kinetic energy and the potential energy. Kinetic energy is basically due to motion of the object and potential energy is due to the position of the object or the configuration within the system. Now, the sum of kinetic and potential energy is called the mechanical energy. Let me erase this. So once again we come back to our same example of the hammer. So here what happens is, when I am raising the hammer, I am doing work on the hammer. So the hammer gains energy which is called as potential energy. This potential energy is due to the position of the hammer at particular height from this surface. So this is the potential energy. Now I am taking that hammer down and hitting on the nail. So I am moving the hammer down. That means now because the hammer is in motion, it has got kinetic energy. Now the sum of this potential and kinetic energy is the mechanical energy which I am using to hit on this nail. So this is a mechanical energy. The sum of kinetic energy and the potential energy is the mechanical. Now let's understand kinetic energy and its form. We have understood that kinetic energy is the energy possessed due to the motion of the object. Let's see different forms of kinetic energy. The motion energy, movement of the object. Now here the boy is kicking the ball. So boy is having some motion, ball is having some motion. Here the boy is riding the bicycle. So all of these are in motion, because of which we say they have energy which we call as motion energy. Now this motion or movement we are able to see. Sometimes we are not able to see the movement, like in case of thermal energy. Thermal energy is the energy in the system due to the movement of atoms and molecules within the system. Now these atoms and molecules, the movement is at very microscopic level or smaller level which we can't see, but they are certainly vibrating, due to which heat is generated, and that is called as the thermal energy. Next is the electrical energy. Electrical energy is the movement of the charged particles like electrons. The electrons are moving from negative terminal to positive terminal. because of which electrical energy is produced. Now this movement we are not able to see. Next is the sound energy. Sound energy is the movement of the particles within the medium. These particles move to and fro, because of which we are able to hear the sound. So this is sound energy. Next is the radiation energy. Sun is the prominent example of the radiation energy. Now here sun is the prime source of radiant energy. In fact, all the regions in electromagnetic spectrum and also the warmth that we feel from the bonfire are all the sources of the radiant energy. One more thing we need to understand and remember is that it is not that only at a time one form of energy is present. Like here sun, though is a prime source of radiant energy, but it also gives heat and light. So at a time there are multiple types of energy present. Now we know kinetic energy or energy is a physical quantity. So we should be able to measure it. Here kinetic energy can be measured by formula half mv square. That means kinetic energy depends upon mass and square of velocity. So kinetic energy, if we want to find, you need to know the mass of the object and the velocity of the object. And obviously the unit of kinetic energy unit is joules. The SI unit is joules and the CGS unit is erg. And we know 1 joule is 10 to the power 7 erg. So this conversion, if needed, you should know this. So that's all about kinetic energy. Now let's understand potential energy and its form. We know potential energy is the energy possessed by the object by virtue of its position or the configuration of the object. Potential energy is basically the stored energy. Now there are different forms of potential energy. The gravitational potential energy, it is the energy possessed by object due to the position above the ground. So in this case, the boy is standing at some height h above the ground. So the energy possessed by the boy is called as the gravitational potential energy. Next is the chemical energy. The energy stored within the bonds of atoms and molecules. These are the bonds of atoms and molecules. That is the chemical energy. Now this chemical energy, though it is stored in these bonds, but then these devices like battery or the food or this can having gas, natural gas, this becomes the medium through which chemical energy can be utilized. Next is the elastic energy. Elastic energy is stored by stretching or compressing of the elastic object by the external forces. So elastic energy is the energy stored due to stretching or by stretching and compressing the elastic objects. Next we have is the nuclear energy, where large amount of energy gets released when the nuclei of atoms are split or combined. Now once again we know potential energy is also a physical quantity, so it can be measured and it is given by formula mgh. So potential energy depends upon mass of the object, the height at which the object is placed and the gravitational force. So this is all about potential energy. Now let's understand the law of conservation of energy. It states that energy can neither be created nor destroyed. Energy cannot be created. We cannot create energy from nowhere, nor can we destroy the energy. We cannot say I have completely destroyed the energy or I have created energy. So this we need to remember, energy can neither be created nor destroyed. It is always converted from one form to another. We do not create energy, but we convert it from one form to another. Say for example here, the cracker. Now here the cracker basically has the chemical energy stored in it. Once we light it, that chemical energy gets converted into sound energy and light energy. So here we have not created any new energy. we already had some energy, the chemical energy, and that we have converted to different form, that is light and sound. So energy can neither be created nor destroyed. It can always be converted from one form to another. Another best example is the water stored in the dam. So basically it has got potential energy. When we make it fall through a height, that water starts running and it becomes kinetic energy. Then we have turbines. This kinetic energy, the flowing water falls on the turbines, rotates the turbines, and we have got mechanical energy. The mechanical energy, it goes through generator, and from generator it goes to the powerhouse where electricity is generated. So here different forms of energy are obtained. So once again, energy is neither created, we are not creating any energy. What we have, the same energy is being converted in different forms. The total, because of which the total energy in the universe always remains constant, because we are not getting any new energy from nowhere. We are already having energy in one form and then we are converting it into another form, because of which the total energy in the universe always remains constant. Now next, let's see the conventional sources of energy. By conventional we means what is available, what people have been using since long history. So conventional sources are the coal, the fossil fuels, the nuclear fuels, the natural gas. These are the conventional sources which people have been using since so many years. These conventional sources are also called as non-renewable sources. Now why these are called as non-renewable? Because once these sources get over, we won't be able to have them immediately, because formation of this sources requires lot many years, say thousands of years. Fossil fuels, coal, these formation requires thousands of years. Hence, these are non-renewable sources. Once they get over, it will be difficult for us to have them or produce them, because their formation takes huge amount of period, large number of years, say thousands of years. Non-renewable energy sources are natural sources that have been accumulated in nature over long time. They have been obtained. Now we are using them because they have been accumulated in nature over long time. Fossil fuels, so many years, thousands of years, there are deposits of plants and animals, their skeleton, which have been kept on accumulated over a longer period, which resulted in formation of this fossil fuels. This cannot be quickly replenished and will be exhausted sometimes in future. If these are over, we cannot immediately replace them. So this cannot be quickly replenished. Replenish means replaced, and will be exhausted sometimes in future, because we are not able to produce them quickly. And once when we are using them, these cause huge pollution. So they cause huge pollution when used. So conventional sources means the sources of energy that have been used for longer number of years. Since history these have been used. So this becomes the conventional sources, or these are also called as non-renewable sources, because we cannot have them immediately. Once they are over, it will be difficult for us to have their new supply, because formation of these sources require large amount of period or large number of years, thousands of years. Now another sources of energy is known as the non-conventional sources of energy. Non-conventional means not very traditional. People were having these sources, but they were not being used or not being seen as a source of energy. These are non-conventional sources. These are also called as renewable sources. The biomass energy coming from the plants or trees, the energy that we can get from these plants or the trees, the organic matter, is called the biomass energy. Energy coming from the sun, is known as the solar energy. Basically light and heat we get from the sun is the solar energy. Then is the geothermal energy, energy coming from the lower layers of the earth. The heat from the lower layers of the earth is known as the geothermal energy. Wind energy, energy coming from the wind due to the pressure disturbances on the earth, on the surface of earth. There will be always the flow of wind. The hydropower energy, energy coming from the ocean waves, the tidal waves, is known as hydropower energy. Now all these types of energy are renewable energy. That means this energy will never get over. These are present throughout. This will never get over. Sun will never die out. Trees and plants will keep on growing. Wind energy will always be there. Geothermal energy will always be there. Hydropower energy will always be there. So these are renewable energy. But this is also called as non-conventional because people were not able to harness these sources to form any energy. Hence these are called as non-conventional sources of energy. So these sources are being produced continuously in nature. They are replenished at higher rate than they are consumed. So the rate at which people are using this energy is less than the rate at which these are produced or replaced. Hence they are inexhaustible sources and they are clean source of energy. Using these sources there won't be any air pollution. So that's all in this video. In this video we understood what do we mean by energy. Energy is the capability to do work. We understood two different types of energy, kinetic energy and potential energy. Further we also saw their different forms of energy. Then we understood law of conservation of energy and we also understood what are the different sources available so that we can have energy. So do like, share and subscribe this channel for more such videos. Thank you.